Now what we're going to get into next here is we're going to talk about the different templates. Now we talked a little about them last week. We're talking about all the different kinds of family templates that Revit provides. If you folks go to the File menu and hover over New. Yeah, we're doing this. Oh, I should show on the screen. There we go. So yeah, go to the File menu and hover over New. So it pops up the side menu there and choose Family. So as I told you last week, there's actually not really a whole lot of different templates in Revit. All the ones that you see that are wall-based are basically the same template. Okay, now what we want to do is we want to build a window tonight that will maintain tangency with the face of a wall, even if the wall is not vertical. Now, if any of you are working on a project in the future where you have a sloped wall, or you have a wall that's going to be maybe partly a roof, if you're doing kind of that sort of geometry, the standard window family, if you were to put a window into a sloped wall, that window would still put itself in vertically, which is kind of infuriating. Windows do not follow the angle of a wall. The regular windows don't anyway. So what I want to do is show you tonight how to make your own window that will follow the slope of a wall, or if the wall is curved, it will insert itself so that it is tangential to the point of insertion. So if you've got a curved wall, that window will insert itself tangentially. Now we can't use any of the regular window templates. We have to use generic model, face-based. This is a special template, and I like this template. I really like that they provided it, because I'll use it for all kinds of different uses. All right, so we're going to open up the generic model face-based template. Now, here's the thing. Remember last week, or which week it was, when we talked about the fact that you can have unhosted templates. So in a room like this, there's no ceiling. So if I want to make a light fixture that lives in this room, if it was a ceiling hosted light object, and many of them are, we wouldn't be able to use it in Revit to build this room, because there is no ceiling, unless you made a ceiling and turned it off. But if we use this template right here, we can turn this into a light object, and so that little square that you see in the background there is just an extrusion. It isn't any particular category. So now what we can do is we can make geometry that will live on the face of whatever we insert it into. So basically here we're going to create a window that can be inserted onto the face of a ceiling, or a wall, or a sloped roof, or whatever you want. So this generic model face-based template can be used for those applications. Now the first thing we're going to do is we're going to go over to the family types dialog box, sorry, not family types, the family category. And we're going to switch it from generic model down to Windows. All right. So now this is done. This is no longer generic model. This is going to be a window. So we are at page 4 of the notes. Now we're not going to do this in, oh, you know what, let's do it in metric. And this actually gives me a good chance to show you folks how to get access to the metric template. So I'm going to go to File and then Close. Not going to save it. And I'll close everything else I've got going here as well, just so it's not in the way. Okay, so File, hover over New, and choose family again. But this time what we're going to do is we're going to go back out a folder. So you'll see that you might be in the English I for English Imperial templates. So go back out to Family Templates and then just choose English. So these will be metric. So we're going to use the metric generic model face-based. So this is exactly the same template as before. All they've done is they've changed the units to metric. Now, you'll notice there is no opening tool. So unlike a door or a window where we could cut an opening through our host face for our window or door, no such luck. We are going to have to use a void to cut through the face of whatever surface this window gets inserted into. So I got to change it to a window first of all. So from generic models down to windows. All right, so that's step 2. Step 3, in the reference level plan view, create the reference plane as shown. So here, create reference plane, and it's supposed to be 800 millimeters from the center. So I'm going to draw it wrong on purpose. You guys can draw it whatever you want, wherever you want. It just needs to be above the center line. So draw a reference plane across like so. So now we're going to put the dimension on after the reference plane has been added. So we'll draw a dimension from the middle reference plane up to the one that we've just drawn. So now that we've done this, hit escape a couple of times and select the dimension we've just added, and we're going to add a parameter for it called opening radius. Opening radius. There we go. Now, you can see in the notes it says that opening radius should be 800. So I will click on my dimension value again and put in that number, 800. So now you are good to go. So now what we need to do is we need to cut a hole through our host here for the window. So the opening radius is 800. We're going to be making a circular window here. So on the Create tab, from the Void Forms drop down, you're going to choose Void Extrusion. And we're going to grab the circle tool. So we're going to start from the center here and go out so that we have the same value. So it's 800 in this case. Now in the notes it shows that you, in the screenshot on page 4, right in the middle of the page there, it shows that there's a dimension for the opening radius, and that there's 2 dimensions to try and keep the circle in place. So if you look on the left screenshot on page 4, those 2 linear dimensions on the left, you don't need them. The only dimension that you need is that radial dimension for the opening. So here's what we're going to do. We're going to ignore those 2 linear dimensions, and from the dimension drop down, we'll grab the radial dimension and put one on our circle, just like as it's drawn in the notes. Now, the opening radius parameter has already been created. There's no need for us to create it again. So if you hit escape a couple of times to get yourself out of the dimension command, you can select that dimension, and you'll find that in the label drop-down list there's already the opening radius dimension, so you can apply this dimension to our void that we're creating here. So now we are on to page 5. So you can see at the top of page 5, we're going to make this void quite large so that we can be confident that it will cut through whatever thickness of wall, floor, roof, or ceiling that it gets inserted into. So we're going to finish the void and then go to the 3D view. And there's our void right there. Now I'm just going to turn on shading here to make it a little easier to see. And I'm going to change the scale too to 1 to 10. Just makes it a little bit less blocky. Now the void is not yet cutting the host. So what we need to do first of all is we need to make the void quite a bit bigger in terms of its depth. It is still not cutting the host though. So we need to use the cut geometry tool. And it doesn't matter which order you do it in. Pick the extrusion and the void, or the void and the extrusion, whatever. Need to get that hole in there. So what will happen now when this gets inserted, that void will interact with the floor or wall that you inserted onto and cut a hole through it to place the window. So now, page 5, step 6. What we're going to do is we're going to go into, I'm going to go into the left elevation view here, and we're going to create a few different reference planes that we're going to use to allow us to control the thickness of our window frame and how far it sticks out proud of the wall. So in your project browser, folks, find the left elevation. And here we go. Now, on page 5 on the center screenshot, you can see that we are adding 3 reference planes. So just watch me do it here, then you folks will be able to pull it off. So not reference lines, reference planes, and we're going to draw 3 of them. One just above the extrusion, another one just below it, and a third one just below that. So we're going to have 3 reference planes like so. So once you've got them drawn, switch back to modify mode. And the top reference plane we're going to call face of frame. Face of frame. The next one in we're going to call face of glass. So click it, face of glass. There we go. So what this will do is allow us to control where the window frame sits within the width of the wall.
All those reference planes?
They are. Yeah.
Yeah, so it's the same page as the circle and the square that we did? You cut the geometry?
I did.
Yeah, it's same as that one? Same page as that one?
Oh, no, on top of page 5 we did the cut geometry.
Oh.
Okay, I'm going to change the scale here to 1 to 10 just to make it a little easier to see all of my dimensions. So I'm switching scale to 1 to 10. And now we're going to use the aligned dimension command here to create the dimensions that you see on our screenshot in the middle of page 5. So here we go. Now I'm going to start with the leftmost one, frame offset from face. So what that is, it's this dimension here. Yeah.
Did you put the first line on the inside on purpose? Because it's different from...
Oh, it's a little different from the notes. Yeah. So I mean, this next reference plane here for the glass, that could easily be, sitting outside like in the notes. It's not going to matter. Yeah. You don't have to worry about it. So just to make it so it looks a little bit more like the notes, I'll draw it like so. Okay, so dimensioning. We are going to dimension from our outermost reference plane, there's the start, down to the face of our extrusion, like that. I'll come back and label it in a second. The next one, the glass setback from frame, is the dimension between these two outermost reference planes. So the first dimension was from the outermost reference plane to the face of the extrusion. The second dimension will be between the two outermost reference planes. And the third dimension will be between the outer and innermost reference planes. So that's approximately what you're going to have for the 3 dimensions. You'll have different numbers, and that doesn't matter. Now, once you've placed those 3 dimensions, we're going to hit escape a couple of times, and we're going to give these things labels. So the one on the far left here, that's going to be our frame offset from face. So we select the dimension first in modify mode. Then we roll on over to the label area, but we have to add a new parameter for it because we don't have one for it already. And it's going to be called frame offset from face. Frame offset from face. Now, if you happen to misspell the parameter, don't let that bug you, because you can go into family types and you can find the row where you've misspelled it and find the pencil icon at the bottom, and then you can rename it as you wish. So again, that's in family types. So the next one is glass setback from frame. That's this guy here. Glass setback from frame. There we go. And the last one is frame depth. There we go. Okay, now I'm going to clean up these values so that they match what we've got in our notes. So slow double click. 1, 2. So now we've got our reference planes ready to go. Just confirm that you've got the 2 outermost ones named, the one for the frame and the one for the glass, and then we can continue. So this is what you should see. So now we are going to build the frame for the window. So from the Create tab, in the Plan view, we are going to choose the Extrusion command. Now, we need to tell Revit where we want this extrusion to be built from. So on the Create tab, you should see the Set Work Plane tool. And in the drop down there, we're going to choose the one for the face of our window frame. So before we start creating the extrusion, or before we start drawing the lines for the extrusion, we're going to choose the Set Work Plane tool and choose the reference plane for the face of our window frame, and then hit OK. So now Revit's going to follow our instructions and use that work plane for this extrusion. Now, try as you might. If you folks remember when we had the opening tool in that window, when we're building an extrusion, we could use the pick tool and we could simply pick the edge of the opening. You folks can see that is not going to work. See, pick tool on, lock option here. I got nothing. So what that means is we'll just have to draw the circles ourselves. So can't use the pick tool, just got to draw with the circle tool. Now start from the center and then go out to the edge of the opening. It should be 800, just like you did when you were creating the opening for the window. So that is our outside edge of the frame. Now we need one more circle that will represent the inside edge of the frame. So again, we'll start from the center. And I think in the notes it says frame inner radius 700. So I'm going to go in out to 700 there. So there you can see it. Draw it to 700. So it's a little bit smaller, of course. So we've got basically a 4-inch frame all the way around the outside. Now, if you look at the screenshot on the bottom of page 5, you can again see that there's a bunch of linear dimensions, and you don't need them. The only dimensions that we need to make this work are those 2 radial dimensions. So we will now use the radial dimension command. And we need a radial dimension for the outside sketch line. So there's the one there. I'll put it where it's going to be in the notes. And we need another one for the inside of our frame, like so. So I've got them right where they're going to be in the notes, bottom of page 5. Anybody need a hand? Yeah.
Oh, okay, so hit cancel, and then cancel the extrusion. We'll go back to your elevation view. Click on the self-explain. Yeah, see what this quick name? Yeah, let's call it. Alright. Yeah, again, it's there. Yeah, so go ahead and scroll basic name. No, and the next one in. Yeah, basic ones. Awesome. So now we go back up to the extrusion. Yep, and set. And you see it. Yep. Yep, that's right. Okay. And now draw this with the circle pad. Click in the center. Yep, go to the edge. 300, yep. Now draw it down. This up. Yep. Perfect. Okay, so now what we need to do is make these 2 dimensions parametric. We already have a parameter for the 800 dimensions, so hit escape a couple of times. Pick 800. You'll grab it out of the list because opening radius is already there. We do not have a parameter for the frame inner radius, so we'll need to create one. So click 700, go up to the new parameter button, and we'll call it frame inner radius. So, folks, what would happen? Now remember, we've got our frame inner radius of 700. What happens if somebody takes the opening radius and makes it 700? What would happen to our extrusion? Boom. Wouldn't work. Rabbit can't make a 0 thickness extrusion. So what we need to do is figure out some way to connect the opening radius with our frame inner radius. So maybe, wouldn't it be nice if we could say that we want the width of our frame to be some number and then subtract that from the opening radius so that our frame inner radius is always what we want it to be. Because you folks know with a regular rectangular window we can put a dimension from one side of the frame to the other and Revit will adjust it. Well, we can't do that here. I can't do I can't take a radial dimension and go from this one to this one. See, it doesn't work. I can't create a dimension between these 2 concentric circles to control the spacing in between them. So what we have to do instead is do some math on this parameter so that it is always less than this one by an amount we specify. Let's do it. So let's go to family types. And what we're going to do is we're going to make a new parameter
without having created a dimension first. So it's going to be a length parameter. So in family types, at the bottom, hit the icon here to make a new parameter. It's going to be called frame width. Frame width. And we will make its value 75. So now what's going to happen is that we're not just going to let frame inner radius here do its own thing. We're going to give it a formula instead. So now what we're going to say, it's case sensitive and spelling sensitive, so you got to get the spelling and the case spot on. It'll be, for our frame inner radius, opening radius minus frame width. So this is for our frame inner radius. It's no longer just going to be the number we used initially. It's going to be based on this formula. Opening radius minus frame width. It is case sensitive. So whatever you've used for those parameter names, find them in the list here, put them into the formula. Now what you will notice is that the value of frame inner radius and the name of the parameter turn gray. If anybody doesn't have that work for them, just wave at me, I'll come and get you sorted. Now, what this means is that in the future, when someone is using this family in their project, frame inner radius can't be really controlled by you directly. So the point is, why even bother looking at it? Can we hide it? Because the user can't really edit it. Well, you can't hide it, but you can do this. So with your cursor still in that same row, you can go down to the bottom here and edit the parameter. Now, what you folks might notice is that we've got these blue grouping headers for all the different parameters inside our family. And you would see this in the project as well. You'd see a dimension header and all the different dimensions are listed below. We can change the group that this dimension sits in and maybe move it down to, say, other. Now as soon as we hit OK, watch what happens. The dimension disappears from this part of the list of parameters down to a new one at the bottom. Now, we didn't hide it, but we put it someplace where the user probably isn't even going to notice it because it's grayed out and it's down at the bottom of the dialog box and they'll probably never even think about it. Meanwhile, all the other parameters that they are going to use will all be up at the top of the list for them to see. So now when you hit OK, you'll see now that your frame inner radius has changed its value and now will not be directly edited by the user, but instead the formula in family types is controlling its value. Okay, now before we move on, we need to change the subcategory to frame and mullion. If you don't see frame and mullion in this list here, it means that you have forgotten to turn this into a window family and you need to go up to the family category dialog box and change it to a window. As soon as you change it to a window, then you'll see these different subcategories appear. So it starts off as generic model face based. When you switch it to a new category, Revit automatically adds these subcategories for you. So that's where they came from. So case in point, I'll go back and switch it to generic models again, and you'll see what happens. Generic models, hit OK. So now look, no subcategories at all. I switched it to generic model. Right? Generic models, Revit doesn't create these subcategories. But when I switch it to a window, Revit automatically adds some subcategories for you to use. That's a Revit thing. So it's frame and mullion.
And you know what, we're going to, is there anything here about creating a material parameter? Probably not, doesn't matter, make one anyway. So here in the material parameter, little gray button, let's add a material to this frame so when someone's rendering it, they can make it look like aluminum or wood or whatever. Little gray button. So what we're doing is we're making a new material parameter for our frame. So the bottom here, new parameter, window frame material. There we go. So now you've got a window frame material as the name, hit OK. And now you'll see that the material parameter is grayed out and there's a little equals sign here at the end just to let you know it's being driven by that material parameter. So it's a frame and mullion, you're good to go. Finish. Now, when we look at what we've got in 3D, you can see the window frame is actually going the wrong way. So what happens is when you first create that extrusion, it extrudes it from the page towards you. So what we need to do is go into one of our elevation views, and indeed you can see it started from the right place, but it's just going in the wrong direction. So what we need to do is grab that extrusion, and you can see this handle here, so I can change its depth. I don't want to move the handle on the reference plane where it started. I want to grab the other one, pull it down, 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 down to the other side of the extrusion here, and I'm going to touch it against that reference plane at the back. And when I release my mouse, it'll show you a lock icon, which you can now lock. Anybody want to see that again? Guys are good? Okay. So now, when we look at it in 3D, that's what we want to see, just like that. Now I've just turned on shading here so I can see what I've done. Your mullion or your frame around the outside should be green, like you're seeing here. Okay, we're at step 8. So we're going to go back to the floor plan view, and we're going to go to the Create tab, and we're going to go to the Set Work Plane tool. So this time we're going to change our working plane to the glass. So we started off on the frame. We're going to switch to the glass. So if you don't see the glass here, again, that just means you haven't named your reference planes in your elevation view. So that would mean in your elevation view hasn't been named yet. So both of those had to be named so that the Set Work Plane tool would be able to recognize them and use them. So, step 8. Okay, create an extrusion. Create extrusion. Set the subcategory to glass in the properties palette. So, folks, we started a new extrusion, and here now, in the new extrusion, we've used the Set Work Plane tool to set it to the face of our glass. So we're setting the subcategory to glass. Then it says, set the extrusion end value to -25. So that means it will extrude the glass away from us, back into the window. So -25. Use the pick tool, right there, pick, with lock enabled. And we're going to pick the inside edge of our window frame. So it picks one side of the circle and then the other. There you go. And that's your glass. So when you finish, you should see that. Sure. So I'm just going to repeat the process here. So in plan, start the extrusion command. Make sure your subcategory is glass. Make sure the end value is -25. Make sure that your current work plane
is the face of glass. And now we're going to use the pick tool with lock enabled and just pick the inside edge of our frame. And finish. So we are on to page 6 in the notes and on to step 9. Now, we have been using reference planes for our geometry so far. Now we're actually going to show you how to use a reference line. Now we're going to go into the right elevation view. Now, again, I think the scale of my dimensions is a little bit too big, so I'm going to switch to 1 to 5. No, 1 to 10 would be okay. 1 to 10. So now what we're going to do is we're going to use a couple of reference lines to help us create a hinge. So reference planes do not like to be rotated. Reference planes, you can move them back and forth. Doesn't mind that. But if you try and get a reference plane to change its angle it's on, good luck with that. They're not designed to do that. So from the Create tab here, we're going to use a reference line. Reference lines are designed to be rotated. So what we're going to do is we're going to draw, first of all, the hinging line for our, we're going to put a shutter over the front of this window. So here we go. I'm going to, and I'm not going to draw it right at the vertical reference plane where it's going to end up. I'm going to draw it off to the side a little bit. And I'm going to go up, about 60 mils. And once I've done that, I'm going to click, so that creates the first reference line. Here's the second reference line. It's going to go up on kind of an arbitrary angle here. There. So you're going to have two reference lines. A short one and a long one that's drawn at an angle. The short one will be right here, right close to the edge of the window, but not quite on the reference plane yet. Okay, what we need to do is add a couple of parameters on here so that we can control how this is going to work. So we need a dimension, an aligned dimension. And we're going to start from the reference plane, not the geometry of the window, but from the reference plane at the top of the window. So watch. Again, you're using an aligned dimension. Start it at this reference plane for the top of the window. There's your first click. And your second click will be right on the intersection where those two reference planes meet. And I'll place that dimension off in space, just beside the other geometries here. So that's step number one. Now I'm going to hit escape a couple of times so I can come back to this dimension I've just placed. And I think the notes say give it a parameter name of flap hinge length. Flap hinge length. There we go. So this will allow us to control how far off the face of our window frame that our shutter pivots from. Now I will use another dimension. So in this case it's going to be an angular dimension. Now pay very close attention to this, folks, because this is something that people often screw up at this point. With the angular dimension command, again, make sure that you do not pick the geometry of the window. For your first click of the angular dimension, pick that reference plane again. Now pick the angled reference line. And there you go. So the next thing we need to do, hit escape a couple of times, select that 18 millimeter, or that 18 or whatever angle you've got, select the radial dimension, angular dimension rather. And we're going to give it a new parameter as well. It's going to be called flap angle, but before you finish it, folks, change it to an instance parameter.
We've been doing type parameters for everything else, but this one's going to be an instance parameter so that each copy of this window that we put into our project can have its own unique amount of opening for this shutter. So it means some of the shutters can be closed and some can be open a little bit and some can be opened a lot. And that way you can kind of give the building a whimsical or a lived-in appearance when you use this window in your project. So instead of having to make a new type every time you want to change the angle of opening for the window, each window will have its own unique value of this flap angle. You'll see it in a moment. So that's where you should be at so far. One last step before we actually build the shutter. We're going to use the align command. Grab the align command up on the modify tab. And now pick that reference plane at the right edge of the window. And now pick that short reference line we just drew moments ago and lock it. Now you'll notice that the flap hinge length parameter changed. No big deal. Just hit escape a couple of times to get out of the align command and go back, and I'm going to make flap hinge length, I'm going to make it 50. In the notes it's 75, I'm just going to make it 50. And now we're ready to move on to the last step of working with this window. Now I'm going to go into 3D, and so here I'm just going to go into hidden line mode. You folks can see this reference line, this one right here. So with these reference lines, they have several working planes that we can use, 4 to be precise. You can see this kind of cruciform shape. Well, there's a vertical working plane along its length, there's a horizontal working plane along its length, and there's working planes at either end. And you can see them quite clearly shown when you select that reference line. Now the shutter that we are going to build is going to be hosted by the horizontal working plane along the length of our reference line. So we need to access it. So with the create and then the set work plane tool, create and then set in 3D. So get into your 3D view, grab the set work plane tool, and now we're going to choose pick a plane. Pick a plane, hit OK. Now when you put your cursor over the reference line, you're going to see it wants to choose the vertical working plane first. We don't want this one, so we hit tab. So now that switches us to the horizontal. So you can see just by tapping the tab key, we could choose which plane we want to build our geometry on. And if you're at the end of the line, you can choose between all 3 choices at the end of the line. But along the length, we want that one. So now you can left click it, and we'll turn on the show work plane mode so that we can confirm that the working plane right now is the one that we want to use. So we're going to build the shutter now that goes over this window. So it's going to be an extrusion. And before we go any farther here, I'm going to switch the subcategory back to, I'll leave it as none this time. So subcategory is none. Now if we want the shutter to have its own material, so if you want to render it as black metal for the shutter and then still have say aluminum, light aluminum for the frame, well then you could give it its own material parameter. If you want the shutter and the frame to have the same parameter, same material, well when you hit the equals button here, you would just make it the same as the window frame. So if I did that now, my shutter will have the same materiality as my frame. But if I want it to have its own material, then I need to make a new material parameter for it. You don't have to worry about doing this, folks. It's just a note showing you how it's done. So now you've got 2 material parameters. One will drive the appearance of the shutter. The other one will drive the appearance of the frame. So this shutter, or this flap that we are going to build now, let's get into that. So you need to be in 3D.
so you can see what's going on. Grab the circle tool, and we're going to draw this circle so that it is centered along this line. So the center point is going to be somewhere along the reference line that you're drawing. So so your center point is there. And I'll make it whatever radius here. It's going to be 800 by the time we're done, so make it approximately 800 millimeters in radius. The center point is just along that green line. Here, let me turn the show work plane mode off. So when I used the center or the circle tool, I made sure that my cursor for the start point was somewhere along the length of that reference line. Can you see it in your view? Okay. Now, two things. First of all, we need to make sure that the radius of this circle is dimensioned. So we're going to go into the dimension command here and grab the radial dimension tool. And you can put the dimension anywhere on the circle. So just click somewhere on the circle. There's our dimension. So associate that dimension with your opening radius parameter. There we go. So that is step one, getting that circle so that it's dimensioned. So its radius will be controlled by the opening radius parameter. That's step one. Now this is the tricky business. Remember we showed you before that when you dimension to a circle, you can dimension to its center or to its near or fore quadrant. So what we're going to do here is we're going to switch to the aligned dimension. And this is where we're going to do a point snap. So here, and you won't have to do anything special, just put your cursor at that point where those two reference lines converge. And when you see that little dot, you're good to go. That's your first click. Your second click is going to be, again, not on the close quadrant or the far quadrant of the circle, but kind of along its side quadrant. That's click number 2. That will place the linear dimension approximately like so. Okay, I'll do it again. So we're using an aligned dimension, and first of all, I'm making sure that I get a point snap where the two reference lines intersect. That's click number 1. Click number 2 is to go along one of the side quadrants of my circle so I get a center snap. Unfortunately, Revit does not indicate that it's center snapping, but it is. Here's click number 2. And that places a dimension from the intersection point of our two reference lines to the center of the circle that I'm drawing. And I'm going to associate this dimension with opening radius as well. So what this does, as the opening radius changes, the circle stays where it's supposed to stay. The circle gets sized to the size that we want. And now that we're done, hit finish. And that's what you should get. Okay, so step 13, save your window as portal window with flap. And just save it to your desktop for now, so that you can use it for the next little exercise here that we're going to go through. Give you folks a couple more minutes, and then we're going to show you how this window works and why it works differently from the standard window. And this is again because we use this generic model face-based template. Now, in the Session 6 folder for tonight, you are going to find a project that's called Massing Project. Massing Project. Just double click it and open it. Now what we have in here are some windows, or not some windows, but some walls rather, that have been placed on massing forms. So we use the wall by face command that we talked about a few weeks ago, so that we have basically non-curvilinear geometry for a wall. Now you're going to see that when I use the regular window command, what happens to the windows when they get placed. So there's that wall. So you can see it curves in 2 dimensions, and I used the massing tool set to create this shape of the building. Now, if we use the regular window tool, you folks can see that, you know, windows place themselves vertically as they do. And that's fine for a vertical wall, but when you put it in this wall that's on a slope, yeah, that's great, Revit. So now that's why we made the window that we just had tonight. So I'm going to insert that family now. So I'll go to the window tool here and I'll choose load family. So again, open up the massing project, then go to the architecture tab and grab the window tool. And now you can choose in the window tool, where is load? What the heck? Okay, let's try that again. Window. There it is, load family. And it's on my desktop, so I'll load it in. So now you can see what happens with this family. Look folks, look up on the screen here. So you can see it's following the tangency of this wall. So I'm just going to throw a few of these guys on to kind of get all Rem Koolhaasy on you here. Now, recall how we made our angle for the window an instance parameter. Here's why. It means I can select this window, and see, look at the flap angle is available to me right now. I do not have to hit edit type. So I'm going to close this window. But the next window, I'm going to open to 45 degrees. And the next one, I'm going to open to 90 degrees. And the next one, I'm going to, yeah, you can see where this is going. This way, it looks like there's a bunch of drunk college students in this building who are just opening these things to any angle they want. So if you're doing a rendering of something like this, it makes your building really look like there's humans in it, right? Maybe not sane humans, but humans nonetheless. So it's a great way to kind of keep your windows from looking staid or lethargic. It's a nice little humane way to express this stuff on the outside of a building. So when you are doing your own windows, so going back to that 313 light, what I could have done was for my operable vent here, I could create, so you can see here's the vent right here, I could do a reference line right from this point here, right? So there's my reference line. And this reference line here could in turn, this work plane along the length of the line could in turn host my vent. So that would allow my vent to be angled outside of the window. So that'd be a really great way to make this window kind of look more like it's being used by real humans inside the building. So that's the power of those reference lines. Okay, so save your portal window into your share in folder. So once you've got it saved somewhere, just open it up in Windows Explorer, right click and copy it, and then find your share in folder on the iDrive, right click on your last name, paste it in. You won't see it that it's going in there, but I will see it when I go to mark your stuff. Okay, I'll give you a couple of minutes and then we're going to move on to talking about arrays. Alrighty, so I'm going to close this down here. We're going to move on to talking about arrays. Now, we did a little bit of this last week when we showed you the louver family. We did some arrays in there. So we're going to continue on talking about that sort of thing and talk about how arrays and families can be made useful. Now, in our session 6 folder, we've got a few different 2-pick families. Now, arrays and families are good when you need to place a bunch of similar objects at the same time. Now, a 2-pick family is a special kind of family. So let me just show you what a 2-pick family is. So in our folder here, we've got stacking chairs. That's one of them. So typical application for this family, placing a bunch of chairs at once. So there's a whole bunch of chairs. Instead of doing copy, 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 you use this family, you draw a line across the screen, and boom, you got a bunch of chairs. Now, another common application would be doing parking stalls. Now you notice this is for the municipality of Surrey. I'm sorry, Surrey, we just have to pave you. Sucks to be you. So here we go. This 2-pick family. So if you're doing something like a commercial development or a mall development, just draw a line across your screen, and there's all the parking stalls that you need. And Revit, of course, counts those stalls so I can make a parking schedule and ensure that I'm meeting my zoning or my parking bylaw requirements with the number of stalls in the project. So again, instead of putting in that first stall and copying it, or putting in that first stall and using the array tool, now I just draw a line across my screen and I get populated with the stalls that I need for my parking lot. So that's a really good application of these 2-pick families. So you can see 1 pick, 2 pick, the second pick places the other end of this family. Another example here. So instead of arraying a bunch of stuff, you can make a family that simply does this. It just draws an arrow across the screen. Now Revit's leader tool, so if you do a leader in Revit with your text tool, it just puts an arrow on one end, and on the other end it's connected to text. This family right here just makes an arrow that can be used to indicate maybe direction of traffic flow or pedestrian flow. So these are all in the session 6 folder, so you can just grab them and use them on future projects. So you can see there's a couple of different kinds there that have different arrow lengths. So that is a 2-pick family. So there is a family template for this. So again, go to the File menu, hover over New, and choose Family. So in here we've got the generic model, line-based. That's the starting point for all of this stuff that we're talking about here tonight. Now you don't have to open it, but that's where these 2-pick families get started. So they're meant to be dynamic length families driven by a length of something in your project so that you can infill between those two locations with something. So it might be parking stalls, it might be chairs, it might be a filler panel on some millwork. So you've got, 16-inch cabinets in this opening. You got 3.5 inches left. What are you going to do? Well, you can make a 2-pick family that builds a little extrusion into that gap and fills it in, and your millwork trade would provide that for you. Now, looking at the bottom of page 6 here, when you make an array, don't forget that you've got 2 different kinds of arrays. So when I put something into my view here, so I've got this chair and I array it. Remember, we've got a second type array and a last type array. Now, the difference between them is important. If you choose a second type array, it's the distance between the first and second member of the array that sets the spacing for all of the others. So the distance between these first and second chairs is 3'1". So shall the others be. Change the spacing between number 1 and number 2. That affects the spacing between all the others. Now, the other kind of array is the last type array. This one's different. In this scenario, you have a beginning member and an ending member, and then you fill out how many you want in between. So now it's the spacing between the first and the last member that drives how they're spaced in between the beginning and the end. So why does this matter? Well, think of your parking stalls. We want to pack as many of those suckers in as possible, 8'6" apart. So the distance between the first and second parking stall, 8'6", is what we want for the rest. No gaps. You guys know how it's like when you're laying out parking. You got to jam those stupid things in as tightly as you can. But with your chairs, it doesn't really matter the exact spacing between the chairs. You just want to start at the aisle and end at the next aisle and just get them in between. So we'll show you how both of those are set up. Okay, page 7. So what we're going to look at first of all here is in our session 6 folder. So we're going to look at the chairs, stacking chairs, 2-pick. So here's the plan view. So the original 2-pick or line-based template, I guess it's a generic model, line-based. All it has in it is everything that you see here except these chairs. There's nothing to it. There's a reference line for some reason. I've never used the reference line for anything. And then there's the starting point of the family, which is the first click. And then the second click is over here where this smaller reference plane is located. 2-pick family. So what we do is we nest in the chair and we do an array of this nested chair. Bring it in, give a parameter for the array like we did with the louver blades. We have a formula up inside our family types dialog box that figures out how many chairs we want based on the length divided by the spacing that people want for their chairs. So it's just simple math. And of course, there's one extra chair added at the end. I'm going to skip that because that's pretty straightforward. Going over to parking stalls, page 8 rather, page 8. So this is a second type array, just like we discussed. So you get the parking stall family, you load it into this generic model line-based family, and you go to town. So you guys know how to nest a family. That's all that you would do. So what we're going to do here on page 9 is we are going to build a dental family. Now I'm not talking like dental as in your tooth. That would be D-E-N-T-A-L. This is D-E-N-T-I-L. This is an architectural dental. All right.
for those of you that don't know what an architectural dental is, on older heritage buildings, when they do the fascia on the outside of a roof, so they'll have a fairly thick fascia board, they'll often have a little bit of a profile on the cornice. They've got a little bit of some fancy stuff in there. So in that location, they will often have repeating blocks like this. Now, if this is the design that you're going after, you probably don't want to just draw them in elevation in 2D and be done with it. It'd be nice to model it. So these things here, dental blocks. So what we want to be able to do is to be able to draw them, starting here and going up to the peak, pick number 1, pick number 2, and have Revit put those blocks in between those two locations. So it's a real fast way to populate my fascia with this architectural feature. Now you could use this for lots of other applications too. If you want to do decorative rafter tails, you could build the rafter tail shape and then nest that in and have that array along the underside of your roof. So instead of putting in that one little rafter tail, modeling it and copying it around, put it into a line-based family, all the way down the side of your roof. Okay, so let's go through that process. So I'm going to close everything down, so I'm back down to the Revit desktop here, just like you see. And we're on page 9. So if you want to follow along after this is online, you'll be able to see right from scratch. So step 1, open a new generic model line-based family. Hover over File, or click File rather. Hover over New, choose Family. And in the list, generic model, line-based, and hit open. Alrighty, so here is the starting point. Now in our session 6 folder it says open the dental RFA. So dental, there it is. So all this little family it's just a little extruded rectangle. Right, not much to this thing. So now that we've opened that, this is the second part of step 1. Open dental and load it into the new line-based family. So up here you'll see load into project or load into project and close. We can actually use that option because once we've nested it in, this doesn't need to be open anymore. So step 2, place an instance of dental RFA in the plan view of the line-based family. Lock its left and top edges to the reference plane as shown by the instructor. So I'm just going to place it down here, like so. And that's good. So you've got that first little block here in this view. Now we will use the align command. Pick the left reference plane first and then the left edge of the block and lock it. And then the top reference plane and the top of the block and lock it too. So our first block is in place. Now, what we are going to do here's our first pick. And so Revit is going to, and what we're going to do is we're going to have the last dental block in here. So it's going to be number first, last, and this will be click number 2 for the user who's placing it. And then we're going to get Revit to fill in here a number of blocks based on the spacing that we want, sort of the nominal spacing between each one of these dental blocks. So that's the goal. That's where we're headed.
So now that this thing's aligned, hit escape a couple of times and select that first dental block. And we're going to use the array tool. And I think we're doing the last option. Select the dental, use the array command with the last option. Drag it to the right about 3 feet. And I'm going to drag it down a bit too, like that. Lock its top and right edges to the reference planes. So what we're supposed to do here is use the align command, pick the right reference plane and the right edge of the block, and the top reference plane and the top edge of the block. So that's where we end up. So we've got our first block and our second block. Now we just need to get Revit to fill in between. So we're done with the align command. Hit escape twice. So now we've got an array here. Got our first member of the array and our last one, just like we did previously. You select one of the members of the array and you click the array connector between them so that you can get its label parameter exposed here. And we're going to add a parameter. Give it the label num underscore dentals. So here, num underscore dentals, and make sure it is an instance parameter. Yes? You bet. So you select one of the members of the array, find the little connector between the two of them, and click it. Don't click the number, click the line. And you'll get the label drop down here. Add a parameter. Num underscore dentals. Now it says in the notes that this new parameter that we're creating has to be an instance parameter. Anybody want to guess why? Cowards. That's what my brother-in-law always says. Ask me a hard question and I can't answer it. He says coward. So mean. The reason it needs to be an instance parameter is that every time you place this thing, it's going to have a different length, right? So you draw it alongside of the building, that's a different length, that's a different length. If it was a type parameter, it would be kind of useless to us because the number of these little blocks is going to vary based on the length of line that we draw. So that's why it has to be an instance parameter. So there we go. Now, obviously, it's not going to be just 2 blocks. It's going to be more than that. So what we need to do now is go into family types. And we're going to have a formula that tells Revit how many of these little blocks that we want. Now, for Revit to figure that out, we need to come up with some sort of a nominal spacing between the blocks, so maybe every foot. So if they're going to be spaced every foot, well, we need 5 blocks. 1, 2, 3, 4, plus the one at the end, 5. So what we need to do first of all is make a new parameter here, dental spacing. Now, dental spacing in this case is actually going to be a type parameter, because when we say that we want these blocks to be at 1 foot apart, that'll probably what we want to do on every fascia that we're drawing it on. So it is indeed going to be a type parameter. And for now, it can't be 0 spacing, so we'll make it 1 foot. So after you've created the dental spacing parameter, make sure you've edited its value to be 1 foot. So down below here is the formula that drives how many of those little blocks get placed in the array. So now we've only got 2. So we're going to put a formula in here. We're going to have the length divided by the dental spacing. Again, it's case sensitive. Plus 1. I see in my notes that the formula just says length divided by dental spacing, but we actually, if they're going to be 1 feet apart, 1, 2, 3, 4. 1, 2, 3, 4. Yeah, if they're 4 feet apart, then yeah, you'd have 1 extra one in there. So, not that it matters that much, but just in the notes it'll say length divided by dental spacing, but in actuality you would need that 1 extra block at the end. So that's it. So you've got a family now that when you draw that across the face of your project, it's going to place these things in. So in the notes it says, save the family as 2 pick dentals. So go to Save As. I'm going to call it 2 pick dentals. There we go. 2 pick dentals. Now, make sure, again, it's case sensitive, and try not to pack in everything here. Like I put a space in between the mathematical operators, so you really should probably do that. It helps Revit understand, and you need to make sure that it is case sensitive and that you have spelled it correctly. Make sure, of course, number of dentals is default, and if it's not, hit the pencil icon and turn it into an instance parameter. So this is actually a good thing to note. When you see a formula listed in family types and it says default at the end, that means it's an instance parameter and not a type parameter. So that might be what you're facing. No? No?
I was going to say, we should come over. Sure.
Well, the way you do is make this difficult, make it spell wrong here, it's like the spell is. Yep. And then go over here and enter this one, and it will automatically update your. Yeah, make sense. Yep. There you go. See, and on that, there. Good. Okay. Dental, see here, oh, you don't have dental spacing grounds. So, you know the stuff that you have? Oh, not yet. Select all this. No, select all this right here. Yeah, Control X, copy. Control X, copy. Okay, and then hit move around here. And call this one dental spacing, just like you have done. Yeah, that's right. Okay. Yeah, that's right. And make that and then number of dentals here, right click and go against that. Yeah, and now you will need this one because you use the spacing. You can go down into that. Yep. And now okay. And beautiful. All right, Jess. Everything bigger? Okay. All right, so let's use this on a project and then we will sally forth. So folks, if you want to go to the, just type in Control N, and from the drop down list choose the architectural template and hit OK. So now you've got this new project open, WA for the wall tool, and grab the rectangle option and just draw a rectangle for your walls. Now what you'll be able to do, we need to load the dentals into this family. So Control Tab, it'll take you back to your dentals family. And now you can load it into your project. Now this family, you can either place it on the face of some geometry or you can place it on a work plane. So for now, you won't be able to place it, well I want to place it on the outside of a wall. So what we're going to do here is we're going to switch to 3D. So go to the View tab and then 3D. And now we should be able to place our dentals along the face of this wall. Now if you folks want to later put in a roof, put in some fascia, and then you'll see that if you use the place on face option, you can place it, it's kind of like SketchUp, you can just kind of place it on any face that you want. So when you're using the component tool, your 2-pick dentals will be in the list, and choose place on face, and you can just draw it anywhere in 3D on your project. Okay, and then at some point here also copy and paste this into your sharing folder. Yes?
What if you wanted to move one of those dentals like that? What if you wanted to move one of those dentals out of place?
Oh, I see. In the 2-pick family, you wouldn't be able to do that. No, no, because they're all kind of very fixed in their orientation. Yeah. Then you do something like that in your project. Yeah, so that way you could move one of them out of the way. Yeah. Okay, let's move on to page 10. Here, I'll give you folks a couple more minutes just to get your files saved. And then we'll talk about the next part here. Yes?
Oh my. Okay, so let's go to your macro town. Yeah. So let's go to town next. Oh, you know, probably the second type already. So this is go to another thing. Yeah. So everything is looking good there. So just cancel. On the create tab, choose, where's the component? Place one out here. Yeah. Escape times. Click that one. Number 8. Okay, so just escape time and leave that. Okay, and you see some capital line come out here. Pick this reference plane. Yeah, stick that into the block. So here, yeah, let's lock it. Pick this one here. And top. That one. And then lock it as well. Okay, go to the first. All right. Okay. And go look at the 3D that says out. There. That what happened was that last block, it wasn't locked yet. So it didn't stretch them out as you drew the line longer.
Now, what we're going to talk about here, we've done a little bit of work with nesting families. One of the capabilities of these nested families is that you can swap out one for another. Worked for a company where we did a lot of millwork in Revit, and so we had a pretty consistent, not consistent, a pretty elaborate set of cabinet families that we built because we were doing them all the time, and it was an important part of the business of the company because it did a lot of interior design. So what we wanted is we wanted to be able to very quickly switch between different kinds of doors on our kitchen cabinets. So if the client wanted solid face doors or shaker style or glass on their doors, we didn't have to go hunting around to load different doors into our cabinets and unload the cabinets into our kitchens. We just wanted to have all that stuff ready to go so we could switch on the fly. Now, in our session 6 folder for tonight, we also have our upper cabinet single doors. If you folks want to open that up, I'll walk you through what this is about. So in our session 6 folder, it's called upper cabinet single door. So what we have here is we've got a cabinet, a box.
So it's just the top and sides, top, bottom, and sides, and a back on the cabinet. Real standard issue stuff, upper cabinet. Now, when you first open it up, you can see there's a particular design for the door, but the door is nested. It wasn't modeled in this family. It was loaded in. It's a casework family, but we just loaded it in. And you can see that there's a whole bunch of other doors here that are listed down here at the bottom in the family, in the project browser. Now, if I click this door, you'll notice that I can use the type selector and switch it to a glass door. So you can see now it's transparent and I can see the glass in the door. Or I can switch it to a shaker style door, like that. Or I can switch it to a slab door, sort of a real basic utility grade door for this cabinet. So they are 4 different casework families, and all it is a door inside them. So what our office wanted to be able to do was, with this upper cabinet family, was to be able to load it into a project and be able to switch between the 4 different kinds of doors. It doesn't sound like that would be that hard. And it's not. It just takes a little bit of setup. Now, in the Family Types dialog box, we've shown that you can create new parameters. And by default, if you're in Family Types and you make a new parameter, Revit makes a length parameter that you would use to put a label on a dimension to make it parametric. So that's the default new kind of parameter that Family Types creates. But you can see there's a whole bunch of other kinds of parameters that you can make. Now, most of these you don't need. There's some important ones though, like the integer parameter. Integer parameters are used in your array. So when it's counting the number of dental blocks that it creates, when you click the little connector line on your array and you went up to the label dialog box and you made a label for your array, it's an integer parameter. Integers, what are they? They're whole numbers. You can't have 6.5 objects in your array. You can only have 6 or 7. It's an integer. So you've got your length parameter. We've seen integer parameter for your array. But this is the interesting one. Family type. We're going to talk about that in a second. Now remember, there was that visibility parameter for your solids. You can make a solid hide or appear. That's a yes/no parameter. So anything that's a checkbox, like you see here, that is a yes/no parameter. Finally, we've done material parameters as well. So that would make a parameter that could be used to control how it appears when rendered. So it's an appearance parameter. But this family type parameter, what it does is it allows us to swap out a nested family. Now here's how it works. I'm going to start from scratch. So in family types, you create a new parameter. In a dialog box that appears, you're telling Revit that you want to swap between different families, different nested families that are in your family that you're working on. So what Revit is asking now is saying, hey, what kind of a family is it that's nested? So it lists all the different kinds of families. It's a casework family. All those doors are casework. So now what Revit will do, it'll say, hey, now you've got a parameter so that you'll be able to sort of choose from all the ones that you've loaded in, any of those 4 different door types, because they're casework. This parameter will allow us to choose between them. If I don't choose casework, Revit's not going to be able to grab those 4 doors. I have to make sure it matches the category of whatever I have nested in. So now this tells the user, you want to choose a different door type? Here you go. Now, look at also the grouping feature. See group parameter under other? What's that going to do? It's going to stick it down at the bottom of the list. This is pretty important. See where it says construction up at the top there? That would put it at the top of the list. Now, you can always come back later if you forget
and put it into the right group. No biggie. So now what happens is you see it says door type casework, and it shows one of the different door types that's there. So I hit OK. So now, what happens when this gets loaded into the project? Well, the person, when they come and they click edit type on this cabinet here, they go into their edit type and they'd say, oh hey, I can switch the door type. I want to go for the glass door. Cool. Oh wait, didn't work. Why? Well, once you've gone to family types and you've made this parameter here, you have to connect this nested door to that parameter. So now this nested door is going to pay attention to the user's choice. And so now when I go into family types, I choose it here, changes it when it's loaded. So this gives you control of how, you know, what kind of what family you want to use when it's nested. Now this only works and this only makes sense if you've got more than one kind of door that's being loaded into this family. If you just had one, well, you wouldn't need a family type parameter, you've just got one. But if you had two and you want to swap between them, that's the process. Okay, so on page 10, you can see that there's a process that you need to go through. You've seen how I've done it here. You folks can wrap that up and share that in next week. One more thing to go over here, and then we are done. Has anybody here had to do travel distance calculations for a building code compliance? Yeah, a few of you nodding your heads. Okay. Would it not be nice to have Revit do a schedule of all your travel distances and be able to put them on a plan that you can show to your municipality, demonstrating that you have your path of travel all sorted out? Wouldn't that be nice? Indeed it would. Indeed it can be done. So if you go to page 11, we're going to talk about the process by which this does work. We're going to talk about shared parameters. Now, shared parameters are a different animal. They're not really that different, but we're comparing them to the regular parameters that you see in your project on a daily basis, which are called project parameters. So what's a project parameter and what is a shared parameter? Okay, so when we look at a floor plan and you see something like a wall tag, right? So we've got a wall type number on it, or you see a door number somewhere. Those are called project parameters. So the thing about project parameters is that they can be tagged, but they can't necessarily appear in a schedule. So what shared parameters do is they allow you to make your own parameters that can be in a schedule and also appear in a tag. So for something like a travel distance scenario, what you want to be able to do is draw a line across your screen that indicates the path of travel, make it traverse as you need it to do in the room, and then finally get to your exit doors. So whatever that length is, you want Revit to be able to total it up and put it into a schedule somewhere so that we can make that happen. So whereas project parameters, you can't create your own project parameters and have them scheduled, but if you use this shared parameters business, it works. Now it's a bit weird, so that's why I say it's a bit of a different animal. So the first step in making this whole business work is going to the Manage tab and connecting your project or setting yourself up with a shared parameters file. Now the idea with shared parameters is that an office will share between all the
employees in the project, or in the firm. That they will work together to come up with some sort of a scenario or a schema for all the different custom parameters that an office would use. And there's not many. And really travel distance is probably one of the few that get used quite frequently in this role. So step number 1 is going to manage and choosing shared parameters. Now out of the box, Revit doesn't care about shared parameters. There's nothing here. Now you can either create a new shared parameters file, or you can browse and point yourself to one that maybe your office has already created. So I don't know that I have one in our, yes I do. There's one here that you folks can connect to. So in Revit, you can either create one from scratch or you can connect to one. So here I'm going to connect to one that's on the desktop here. It's just a notepad file, nothing to it. So now you'll see that already in the shared parameters file, there's a few different groups, and they're easy to set up. And you can see here in my code group, I've already got a parameter called travel distance. It's a length parameter. So if you're here, if I want to create a new parameter, I can just say what it is and give it a name. So it's a fairly straightforward process. Anyways, that's that. I've created a connection between Revit now and a shared parameters file I created years ago. So once you've made it, keep it, don't delete it, point your colleagues to it, have someplace on your server where you're keeping it, and don't muck about with it too much. So now what we're going to see on page 11 and so on is the process by which you can create your own travel distance family. Now I have already got one, so I'm going to show you how it works. And I'm just going to make sure I already have a list of travel distances, don't I? Yeah, I do. So let me just show you here from the business office, L2-part storage. Okay. So at the end of the day, this is what you are going to get. I don't know where it is. It's got to be somewhere. Oh, no, here it is, exit plan. Okay, right here. See this line? This is the family we're talking about. It is a generic model family, line-based, just like we've been using all over tonight. And it shows this path of travel here. And then we can make a schedule that shows the list of all the different travel distances that we would have in a project. So here I've got one, it's 31 meters, and the other one's 21 meters. So I can compare that to the building code and make it happen. So go through the steps on page 11 to 13 so you can see how that's done for yourself. And then you can implement that on your own projects. Okay, so that's going to be it for the lecture tonight. So we'll leave the rest of the time for working on your term project and dealing with any questions you might have.